Hello everybody. Today we're going to look at solubility curves. Solubility curves are graphs which tell us when a solution is saturated. It can tell us when it is the solution is unsaturated, saturated, or even supersaturated. It helps us work out how much solute will dissolve into the solution if the temperature is different, or if we perhaps drop the temperature of the solution, it'll tell us how much of the solute will precipitate out. Solubility curves are graphs that show the maximum solubility of a substance over a range of temperatures. To make a solubility curve, you need to do some experiments to find out how much of a substance will dissolve at 6 or maybe 10 different temperatures. Plot these points on a graph showing the concentration on the vertical axis and temperature on the horizontal axis. Connect the points of the graph with a smooth curve, and then use the curve to show the supersaturated areas which are above the curve, the saturated areas which are on the curve, and the unsaturated areas which are below the curve. Here we've got some information for copper sulfate, and I'm going to show you how to very quickly do a solubility curve. We need to mark up the graph paper first, so let's put, just pick a different size here. Let's pick 50 degrees here and 100 degrees here. And then we've got the solubility, seems to go from 23 to 84. So I'll put 50 and 100. And the units are grams per 100 milliliters. Okay. So our first point, let's get some dots going here. First point is 0 degrees Celsius and 23, which is about there, and 10 degrees and 27.5, which is about there, and 30 degrees, which is here, and that's 38. Which is about there. We've got 60 degrees and 62, which is about 60 grams. It's 50, 62 is about there. And 80 degrees and 84 grams, 75, 84 is there. Okay, so there are the points. If we were to make a nice curve that matches those up, this one seems a bit low anyway. It's going to look something like that. This graph, this point seems a bit low. Why is that? 30 and 38. No, that's right. All right. Okay, first off I'm going to mark up the graph paper. We've got 0 degrees Celsius there, 50 degrees Celsius there, 100 degrees Celsius there. And we've got solubility in grams per 100 milliliters. We've got 50 there and 100 there. That's grams per 100 mil. And we need to put some dots on the paper. Put out the dots there. We're going to have at 0 degrees it's going to be 23, which is about there. At 10 degrees it's 27, which is about there. At 30 degrees it's 38. That's about there. At 60 degrees it's 62. 60 degrees. 50, 62 is about there, and at 80 degrees, 75, 80, it is 84, 75, 80, 84 is about there. And we need to join those dots up with a line that goes like that, basically going between all the different points on the graph. So there's a solubility curve for copper sulfate, and that's how you draw one up. It doesn't necessarily take very long. Next thing we're going to do is take a look to see how you can use a graph like this. So here's a solubility curve for a different chemical, barium nitrate, and the question that's being asked is, if we cooled 100 milliliters of a saturated solution from 60 degrees to 40 degrees Celsius, how much solution would precipitate? Now we just need to make sure that we take note of what the units are here. So this is grams per litre. That's a different unit from before. Let's try and find out where 60 degrees is. There's 60 degrees. So we go up to and find our saturation point there. And we're going to cool it down to 40 degrees. And the question is, how much of the material is going to come out? Well, at 60 degrees, we've got just this much here, about 200, and at 40 degrees, we've got this much, 150. So the difference between 200 and 150 is 50 grams per litre. Now, we don't have a litre of the solution. We've only got 100. So it's going to be less. It's going to be 10 times less. It's going to be 1,000 millilitres on 100 millilitres. That's 10 times less. So we've got 50 times that number is going to give us... that's not right. So we've got a question now on barium nitrate. It's a different chemical. The question says, if we cooled 100 milliliters of a saturated solution from 60 degrees to 40 degrees, how much solute would precipitate? We better just check that we know what the units are. This units here are grams per litre. That's a little bit different from our other one. At 60 degrees, we've got a point here on the graph. And at 40 degrees, we've got a point down here on the graph. If we read across to how many grams per litre that is, we've got 200 grams there and 50 grams there. So the difference between 200 and 150 is 50. So I just pop that down there, 50 grams per litre. But we don't have a litre. We've only got 100 millilitres of solution. So it's 10 times less. It's going to be times 100 over 1,000. And that's going to give us an answer of about 5 grams. 5 grams will come out. Now, another thing we might have to look at here is another question. Different question now. If we warmed 500 millilitres of a 50 gram per litre solution from 0 to 40 degrees, how much more solute could we dissolve? So we'll take a look at our graph. We've got going to have, let's see, 0 degrees is here, so there's our point. And we're going to warm it up to 40 degrees, that's over here, so we'll go up to here on our graph. How much has it changed? Well, it's gone from this number here, that's 50, up to 150. The difference between 50 and 150 is 100 grams per litre, but we don't have a litre. We've got 500 millilitres, that's half. Okay, so we're going to multiply it by 500 over 1,000 because we've only got half a litre. We've only got 500 millilitres. So it's going to be half of that, so that's going to give us an answer of 50 grams. 50 grams more could dissolve into 500 millilitres of the solution. Okay, now a question for you. If we cooled 100 millilitres of a 200 gram per litre solution from 80 degrees to 40 degrees, how much solution or how much solute would precipitate? So the thing to take note of here is that we're going to go from 80 to 40. So we're going to go from around here to around here. You have to find the difference between those two numbers over on this left hand side. But remember, when you get your answer, that we've only got 100 millilitres of the solution. So you have a go. Tell me what your answer is. Email me, let me know. If you've got any questions, ask the questions by email, and I'll get back to you as soon as I can. Thanks.